Hi everyone, this video is on exercise 9i, the second question of the challenge. We have the curve C with the following equation, which is a quartic function. And in part A, we want to show that C has at most 2 points of inflection. Okay, so the framework is the same. When we want to find a point of inflections, we first find the second derivative and then set that equation equal to 0 and solve that to find the points of inflection. Of course, there is going to be a final test at the end, but this question is a slightly different. So we are not going to quite do all those steps, but what we are going to start with is obviously finding the second derivative. So we first find the second derivative. So we have divide dx is equal to 4a x cubed plus 3b x squared plus cx plus d, and then the second derivative is equal to 12a x squared plus 6bx plus c. Okay, now at this point we set this equal to 0 and then solve that and find the points of inflection and so on. But here this is not really the point of the question, because if you just read the question carefully, it says that just show that it has at most 2 points of inflection. So it's not saying that show that there are exactly 2 points of inflections. It's just saying that show that at most 2 points of inflections. So what we need to realize is that the second derivative is a quadratic function. So we have a quadratic equation. What this means for us is that a quadratic can always has at most two solutions. So we know that this is a fact. A quadratic can has at most two solutions. So since it's a quadratic, the second derivative is a quadratic, so we can conclude that there can be at most two solutions, or which means 2 points of inflections. So since d squared y dx squared is a quadratic equation, there are at most 2 points of inflections. And yeah, as you can see, the question is actually much simpler than it might seem at the beginning. Okay, now for the next part, we want to show that if 3b squared is less than 8ac, then c has no points of inflection. So this part is also somewhat similar to the previous part, in a sense that, again, it's not about the typical point of inflection questions that we solve the equation, find the solutions and so on. So it's about just the property of quadratic equations, because we want to show that we want to discuss a condition under which there is no point of inflection. And basically all you need to remember here is that in a quadratic, the case that there is no real solution is when the discriminant is less than 0 or is negative. And when it's negative, then that means there are no real solutions, which means there won't be any points of inflections because there are no solutions to begin with. So all we need to do is that we just need to find the values for which the discriminant is less than 0. And if we do so, it just automatically proves the second question. So we want to find when the discriminant is less than 0. So when b squared minus 4ac is less than 0, which means, so b squared, we need to use the values from the equation. So the quadratic equation, which is d squared by dx squared. So b squared is this value of 6b. So it's going to be 6b squared, which is 36b squared. And then minus 4 times a, so a is 12a in this equation, times c. So the value of c is actually just okay, I just realized that here I made a mistake when I was differentiating, because here if we go back to the first step, the function has the term cx squared, so the first derivative is going to be 2cx, not cx, and the second derivative is 2c. So that means here we'll have 2c. So Now this is the inequality that we have. So it's going to be 36b squared minus 4 times 2 is 8. 8 times, I mean, minus 4 times 2 minus 8 times 12 is minus 96. AC is less than 0. So we can move the second term to the right hand side. So we have 96 AC, because remember here the form that they have asked us to have is b squared on left and then AC on the right. So we can divide both sides by 12, and if you do so, we'll get 3b squared here, and then here 8 AC. And this is exactly what we wanted to prove. So therefore, for the values of when 3b squared is less than 8 AC, the discriminant is negative, which means it has no solutions. And if it doesn't have any real solutions, there won't be any points of inflection. Okay, so that's it for this video, and thank you for watching.